Okay, so let's do this confidence interval. All right, and so first of all, let's do our conditions. The first one is random. And we have to assume hopefully ABC would know how to do that. 10% condition. And so I'm going to say 250 is less than 10% of all young adults. And then let's do success failure. And so we have 10%, so 0.10 times 250 is equal to 25, which is greater than 10. And then 0.9 of 250. Did you ever realize it's just going to be whatever 250? It's going to be 225. 5 is greater than 10 because these two numbers add up to 250. So conditions for a one prop Z interval exist. Okay? Basically what we want to prove that it's a normal distribution. Okay? We just proved that a normal distribution is okay. 92. All right, so let's go to my next page. So I have 0.10 plus or minus now 92. So that's going to be 1 minus 0.992 divided by 2, which is 2.4. I'm going to go to inverse norm and put in 0.04. And I get 1.75. That's my critical value. And then I'm going to do point, go away, 0.1, times 0.9 divided by 250. All right, so I'm going to go to my graphing calculator. I'm going to go, and my hits are 25 out of 250 for a 92% confidence interval. And I get 0.0668 to 0.1332. Okay? And so I'm going to say we are 92% confident that the true proportion of 250 young adults who believe that Judge Judy sits on the Supreme Court. I did hear this on the news, that's why I put it in here. Is between 6.68 to 13.32%. Okay, here we're going to do the sampling distribution. So remember, you need to do this. So I have my horizontal line, my bell-shaped curve, my mean, which is my mean, my mode, my median, and it's 0.2. Okay, so off to the side, I have to go find my standard deviation, which is 0.2 times 0.8 divided by 100. So what is that? 0.16 divided by 100. Take the square root of that. Take the square root of that number, and I get 0.04. Okay, so if I go 1 standard deviation, I get 0.24. If I go 2, I get 0.28. And if I go 3, I get 0.32. So now let's go the other way, and I get 0.162, and I get 0.12, and 3 I get 0.08. Okay, let's change colors here. Now remember, 1 standard deviation is 68%, 2 is 95%, and 3 is 99.7%. And my title is proportion of people who watch the shopping channel. Proportion of people who watch the shopping channel. Or, yeah, network. Sorry that ran into there. Okay. Okay, so now let's go to B here. Would it be, I gotta erase this because I can't see. Would it be unusual that cable company learns that 25%? Okay, so let's go find 25%. Do you see 25? Oh, I'm still in the eraser mode, silly goose. 25% is right here. Is that within 2 standard deviations? And the answer is yes, so I'm not surprised. So the answer is no, because 25% is within 2 standard deviations from the mean. Okay, great. All right, so this is a solve for n, so we need to remember that margin of error is equal to my critical value times p hat q hat divided by n, and take the square root. Now, I don't see p hat here, so I'm going to do 0.05 is equal to, and what do we have? Well, a 98. So 98, so 1 minus 0.98 divided by 2 is 0.01. So I go to the inverse norm of 0.01, and I get 2.33. 2.33. Now remember, it when we don't have p hat, we're going to use 0.5. Okay, so the first thing I'm going to do is I'm going to take 0.05, and I'm going to divide by 2.33, and I get 0.021. And this is 0.5. Sometimes I think this thing is out to get me. Okay, so now I need to square both sides. And so I get 4.61 times 10 to the negative 4th is equal to 0.25 divided by n. Remember, these things just do the do-si-do, so I get n is equal to 0.25 divided by 4.61 times 10 to the negative 4th. So I'm going to put 0.25 divided by my ants, and I get 541.18. If you want to say that's 542, go right ahead. I'm going to say 541 people. This is the best way to do that. You see how I have my math and I have the exact answer, and then I tell what the reasonable answer is.